Yes.
Hello, everyone. Welcome. So today we have two speakers. I think some of you are new faces, not all. Okay, so we have Triv and we have TC. And both of them are going to talk about almost the same topics, but TC is going to go deep into the technical side. I think Triv is going to talk about more on the search MEV side, right, of the things, right? So TC is one of core members. Both actually, in fact, both of them are the core members of ETH Penang. So I don't want to further drag the time, so pass the time to TC.
Testing. So good evening, everyone. So it's TC here. So today I'll be talking about the key features of Uniswap V3s. Moving on to the next slide. So today's the topics are broken down into 4 sections. And then the first one is I will go through to what is actually Uniswap and then how does the protocol actually works, like how are the basic operations are applied in Uniswaps. And then also the features and limitation of the Uniswap V3 itself, as well as what is new in the Uniswap V4 protocols that just released like months ago. So let's start with what is Uniswap. So Uniswap, as you know, is a DeFi protocols where people can actually trade and exchange cryptocurrency without centralized entities. So meaning that you can do this without an intermediary. Everything is done automatically on chain. So this does not require intervention of any centralized entities. So this is a basic definition what a DeFi protocol is. It's a set of rules or programs that let people use financial services from lending, borrowing to funding. So everything runs automatically using smart contracts deployed on the blockchains. So actually how Uniswap works. So now I'll provide a basic intuition on how the Uniswap protocol actually works. So Uniswap actually operates using what we saw in basic market as well. So it actually follows a supply and demand rules. So it means that when more people buy certain stuff, the price of it tend to rises. So let's say that there's both tokens in the pool. The first one is Ethereum, and then the second one is USDC. So when actually more people buy ETH, there is less like buy ETH, then there's less ETH in the pool already. And then people actually deposited their USDC to exchange for the Ether itself. So when there's less Ether in the pool, the price of the Ether will rise. So and vice versa, when more people sell the ETH, there's more ETH in the pool because they deposited back into the pool, and then the price will go down. So it actually follows the supply and demand rules. Moving on to the next slide. So this is the intuition behind Uniswap. So Uniswap actually uses a formula to keep the trades actually fair. So the formula is quite simple and straightforward. It's basically X times Y equal to a constant. So the constant actually stays the same whenever the token moves in weather directions. So let's assume that there are 2 tokens in the pool, and then the pool actually start with 10 ETH and then 1,000 USDC. So the constant is fixed at 10,000. So it's basically K is equal to X multiplied by Y. So let's say that someone bought 1 ETH, and then the amount of ETH in the pool is deducted by 1. And then we plug in the formulas to calculate the price, the USDC price needed to keep the K equal to 10,000, meaning that once 1 ETH is removed from the pool, the price of the ETH rises. So for the next user after this trade, mean that if they wanted to buy Ether from this pool again, they have to pay more for that because the supply and demand of the token has changed already. So after the trade, the user will be paying 1,011 USDC for ETH. But let's say that if the trades go either direction, there are more USDC in the pool now, and then the amount of the ETH stays the same, and then the buyer will pay less for the ETH. So far, any question now? Because we are going into the technical parts already. Basically, it's the max itself. So one thing to note about DeFi protocols for exchange, for DeFi swap exchange is that there's a risk of impermanent loss. So impermanent loss is defined this way because the losses itself is not permanent, meaning that the max actually in the token itself actually might cause user to lose money. So let's start with a simple example. So suppose you are a liquidity provider, and then you add 10 ETH and 1,000 USDC into the pool itself. So we plug in the formula, and then the total asset value, which is the liquidity in the pool, is the total asset value. It's basically 2,000 USDC because 1 ETH is worth 100 USDC, and then 10 ETH is worth 1,000 plus the 1,000 USDC deposited into it. So this makes the total asset value 2,000. And then LP will receive the LP tokens that represent 100% share of the pool in this case. So this is for them to claim back their token and then to receive the rewards. So let's say that another trader buy the ETH, like the previous case that we mentioned previously. The price of 1 ETH has now become like 123.46 USDC. So the total asset value has to be recomputed because the supply balance of the pool now have changes. So we plug in the new prices, and then the total asset value is now 2,022.25 USDC after the swap, meaning that this is what the LP has in the pool itself. And then if the LP, they didn't deposited the token into the pool, instead they just held it. If the asset value actually rises, then they will actually make more money than now. So it means that they actually lose some money when they deposited the token into the pool because the supply changes and then the price change, the max actually make them suffer some losses. But this loss is impermanent, meaning that if the supply of the pool, let's say that the 9 ETH return to the 10 ETH, if someone sell sell one of the ETH and then deposited 1 ETH back to the pool, then the loss will be like it actually never happened before. So the loss is actually impermanent and disappear if the price return to where it actually started. So 1 ETH equal to 100 USDC. And this is the basic intuition of Uniswap V3. So in Uniswap V3, it's more different than Uniswap V2. So for the previous example we mentioned, actually all the liquidity are provided are distributed equally in the pool itself, meaning that there's no certain price range user can select to choose what price range they wanted to supply their liquidity. But in Uniswap V3, we have the options to do so. Uniswap V3 actually let user define certain price range they provide their liquidity with. And then it means that your entire liquidity will be converted into a single token, and meaning that you will hold only one token when the price of token move above or below the range. So unlike V2 that actually spread the liquidity equally in all prices where user cannot define any range, so in V3 we are able to do so. And then this actually greatly improve capital efficiency because user can choose whether they wanted to provide liquidity in whether range they wanted to do, they selected. And then this actually provides better controls. And because there's more capital efficiency, and then this actually reduce the risk of impermanent loss because they are able to select the range, they are able to control the risk level. And then Uniswap V3 is basically allow concentration liquidity to act like limit orders. So a limit order is basically an order you place to buy a certain asset at a specific range. So this actually make it possible to provide liquidity using a pair of tokens within a specified range. So any questions so far? Okay, then I will move on. So moving on to the next, I will be not going detail into this, but this is just a basic intuition on how the max of the Uniswap V3 actually works. But is actually derived from the max of the Uniswap V2 itself, except that is applied when we take into consideration of price range. The formula is somewhat more complicated, but it still follow the basic intuition of how Uniswap V2 works. Rather than we look at supply and demand of the whole price range on the pool itself. So each liquidity range now has their own formula for computations. So one thing to note here is that Uniswap V3, unlike V2, they actually use a different format to compute the liquidity amount. Unlike what the V2 does, where we don't have to take care of the format. So in V3, we have to use square root price because it actually turns complicated price range. Because as we know, all of the mathematical formulas for linear is more easier to work with, but the pool actually follows a curve shape. So the square root price is to simplify the max and then turn the complicated change into a linear relationship. And then these are the formulas of the liquidity pools for computing the price range. And then the liquidity value, as mentioned previously, is basically the total amount of money in the trading pool. But in this, we take the factor consideration of price range into it. And then this is one of the basics snippet that actually compute the liquidity of the Uniswap V3. So I will not go deep into it. So if you wanted to understand more, so there's a link I can provide later for someone that's interested in the max itself. So you can provide as much liquidity as both tokens can support together. So the minimum liquidity is always used. So in this formula, we compute the liquidity for both token value, but we only take the minimum because we must always ensure that the token amount is sufficient for the swaps. So this is the second slide for the max of the Uniswap V3. I will not go deep into it, but just provide user a basic intuition on how it actually looks. So moving on to the next slides, because I wanted to focus more on the features of the Uniswap V3 itself. So these are all the formulas that basically applies on the swap. For the previous phase, we are computing the liquidity, and then for this phase, we are computing the swap amount based on the tokens amount that user has supplied into the protocols. So let's talk about one interesting update about Uniswap V3 compared to Uniswap V2. So in Uniswap V3, there's a different thing known as an NFT liquidity position. So all of the position in the pool itself are represented in NFT. So meaning that they are unique, and then once the position is being created for certain price range, they cannot be recreated already. Means that everything is unique. So some basic intuition about what the NFT is basically a digital asset to represent something unique. And LP position are represented as NFT Uniswap V3. So each LP, which is the liquidity provider, set a custom price range. And the fourth part that is not part of this, but it's like a bonus info, is that in the previous Uniswap V2, fees are auto reinvested back into the pool because users are holding the LP tokens that correspond to the stake they are owning in the pool. But in V3, fees are actually stored in the position itself, meaning that they can collect the fees for the liquidity position that they provided. And then the second features of the Uniswap V3 is that it has a flexible fee options. So Uniswap V3 let liquidity provider define their range, but they are limited to certain ranges only. So the price range from low, medium to high. So for the fee, for the lower pair risk is around 0.05%. And then for medium risk pair is around 0.3%. And then for high risk pair, which are tokens that are not commonly traded on the market, the fees is set to around 1%, which provide user, the LPs, like better reward if they are able to supply liquidity for tokens that are not traded that oftenly in the market. So to encourage more LP providers to provide liquidities on different types of tokens, not just like a few several types. And then there's one thing that's different from Uniswap V2 is that Uniswap V3 uses advanced Oracle. So for also to explain what Oracle actually is, so an Oracle is like a max helper that keep track of the token price over time in Uniswap. So other apps can actually use these prices safely because these are computed in the chain itself. So it means that they are not susceptible or they are less likely to be manipulated by an external malicious parties or affected by an external event. And Uniswap V3, it keeps a timeline of snapshots for the past 9 days, meaning that you can only track back the price for the past 9 days because they need to use this to compute the new liquidity. So once the old data reaches certain range, so it means that it will be overwritten, meaning that the Uniswap V3 always keep a list of records, but it will be reiterated and deleted again and again. So Uniswap V3 improved on the V2 Oracle system by using TWAP snapshots. Basically, TWAP is what the timeline of price snapshot actually means, the range of price over time means, to compute price and then making it more reliable than the V2 itself. Because V2 does not maintain a timeline of price snapshot over time. They just maintain a fixed range only. So moving on to next, what is actually new in Uniswap V4? Since we talked about V3, now we are moving on into V4 already. V4 is the recent update released by Uniswap, by the Uniswap teams. So it actually provides 4 core features. So the first one is custom AMM logics. So actually Uniswap V4, it provides the feature of hooks. So hooks is like an extend to the smart contract itself. It actually provides the tools and abilities for user to define different pool logics. Meaning that using the first logic itself, user can apply their own dynamic fee structures. So meaning that they can define their fees based on other factors and considerations. So for example, for other factors, right, we can trace whether what the external event that has been occurred on the outside world. So if you're able to take into this, then this actually create a lot of new use cases and possibility for Uniswap V4. And it also allows user to apply their own custom TWAP and TWAMM. Basically, it means that users are able to use their own Oracle instead of in V3, you are fixed to entitled to only use the Oracle provided by the team. In V4, you are able to do so since you are able to change the logic. And then Uniswap V4 actually uses a singleton pattern. So all liquidity only are stored within one smart contract. So the main purpose of this is to reduce the gas fee. Since we know that the pool originally in V2 to V3, they are deployed in different smart contracts. If you wanted to route transaction across smart contract, then this will actually spike up the gas fee. So by actually utilizing a singleton pattern, so we are able to bring the gas fee down, making the protocol more efficient for users and more attractive for LPs provider to provide more liquidity. And this is basically the last slide already. So it's like a roadmap of how Uniswap actually evolved, starting from V1 till V4. So these are all the basic features from all the tokens pairing, just to provide a basic flow for user to understand how Uniswap actually has improved its features over the past few years from 2018 to 2025. So these are the notes, and then as we mentioned, what the TWAMM is. So it's basically big trade that is done slowly and smartly over time using certain techniques. And then this actually stopped Bitrate from crashing price, alleviating effect of MVV front running and obtain a better average price. So thank you everyone. So that's the end. So now we are open for Q&A sessions. And then this is a QR code for anyone interested to join the Ethereum Penang communities. So any questions so far from the audience side? So if no question, So in V3, oh, okay, I will just. This mic is not usable because the button is, there's an issue with the button. So V3, you have multiple liquidity plans with different ranges, right? But how do you efficiently calculate how much liquidity is available for purchase of single spot contract? In Uniswap V2, it's very simple, because all liquidity is in the same range, so you always know how much is available. But for V3, it seems like still linearly with every different liquidity provider position, and just seems like something that could quickly cross the markets. But it doesn't work. So how does actually, the liquidity formula it actually works this way. So within certain price range, right? As long as there's something known as an overlapping range. Let's say that user provide a liquidity between the price. Let's say the Ethereum price is around, they wanted to provide liquidity between the 3,000 and 4,000 range, right? And then another liquidity provider created a position. They wanted to provide around the 3,000 to 200 to 3,700. There's an overlapping range. So the formula itself actually, it takes this into considerations. So there's an active liquidity position based on what the user wanted to swap, based on the current price. So when user trying to plug in the formula, whether how much token they wanted to exchange right now, the algorithm itself is actually able to find the active liquidity for the overlapping position. So meaning that everything is done automatically based on the liquidity amount. So even that you say that there is no liquidity provider on the position that the user wanted to swap, the algorithm itself will look for other active position for that. And then it will actually, of course, like if the user wanted to exchange within certain range and then the range is not available, right? Uniswap will advise the closest range that is closer to the user range. And it depends on the user preference whether they wanted to proceed or so on. So there's such a possibility that user might not find the correct liquidity range for that, but there are protocols, algorithms specifically tailored to handle this. Does that answer your questions? I think someone, So any more from the team? You have questions, right? So if no question, I will pass on to Triv. So Triv will be extending on my part, but his one is more to the trading side. So basically, he will brief you through the concept and the technical implementation of how to do arbitrage in Uniswap V3. Thanks.
Okay, good evening, everyone. So my name is Triv. I'm an MEV searcher. I want to talk about a very quick and dirty talk about arbitrage calculation specifically for Uniswap V3. We'll touch on Uniswap V2 just to introduce to you the concept on how we solve the problem of arbitrage. Disclaimer, this is I've never done arbitrage for Uniswap V3. I think this is how they do it. I don't know if there's the new method or a more advanced method, but I want to introduce to you the way of thinking of how to do arbitrage between pools, not necessarily even Uniswap V3 specifically, okay? So we'll do some simple maths, but we'll touch more on concepts that I think will be helpful. Just to introduce what is arbitrage, you have price differences between two decentralized exchanges. So one might be cheaper than the other. Let's say ETH is 2,000 on one pool, but 1,900 on another pool, USD on another pool. So there you can buy from the cheaper pool and sell on the expensive pool. You can also sell on the expensive pool and buy back cheaper. So just want to make you understand. As long as you sell high, buy low, it works. Okay. This happens a lot more during volatile market periods. Why? Because everyone, when they want to sell something, sometimes they become price insensitive. They just sell, at their favorite decentralized exchange, and so they don't think about where is the best price I can get. So that's how you get a lot of fluctuations in the market. And this is, so an arbitrager, which is someone who does arbitrage, will help balance out the prices of all the different decentralized exchanges. This is good for market efficiency, which means that you don't have to think about where can I get the best rate. You can be somewhat certain that an arbitrager has closed all the price gaps between all of the decentralized exchanges, and you can get a good price at your favorite decentralized exchange. Right, so the biggest issue or the problem we need to solve is calculating the optimal size. Why? Let's say we have two tokens that are trading at two different prices in two different liquidity pools, like we started, right? So it looks like this, right? Pool 1 has 10 ETH and 20,000 USDC as a pair. So which means that 1 ETH is 2,000 USDC for the pool 1. But pool 2, it's 20 ETH to 20,000 USDC. So if you divide, 1 ETH is 1,000 USDC. It's a bit extreme example, but I want to show you that this is how you think about what is the current price of ETH or any token in the pool, right? So how do you calculate the optimal size that yields the most profit? So this is quite interesting, right? It's not intuitive because one has, it's an extreme example, but it's hard to think about it. The way or the flow of it looks like this, something like this, right? You have an X that goes into pool 1 as ETH. Then you get back USDC, you use that USDC into pool 2, and you get X prime. The comma or the apostrophe on the bottom X, called it X prime, which is the final output once you've completed everything. Okay? One naive method is to test on different ETH amounts. So let's say you have a program. Okay, I'll just test 0.001, 0.01, 0.1. After you've done like until, I don't know, 100 ETH or however much money you have, then you'll just pick which one is the biggest profit that you'll get, right? There's a better way to do this, which is you have your profit equation, which is amount out minus amount in. So that's kind of obvious, right? In the X term, it's X prime minus X. That's your final profit that you'll get. The optimal size is the amount in when you differentiate profit over amount in is equals to 0. What does this mean? It's okay, I'll explain it, so don't worry. Okay, this equation, well, what is it saying? Okay, profit is equal to the output minus the input. This one is quite obvious. Now, when you think about it intuitively, if you use very small amount, you won't get a lot of profit because you're using small amount. But if you use too high, you're going to lose a lot in fees. So there's like one extreme where it's very small and another extreme where it's very high. So intuitively, you can think of the profit function like this. It's a curve, right? At the start, it's like very small. Because you're using very small amounts. At the end, you'll be paying a lot in fees and also in price impact. We'll touch on price impact in a bit. So you want to have this kind of sweet spot. And how do you find this sweet spot? Okay, if you differentiate the profit equation, we can get the slope at any point of the curve. I don't know if you remember, if you differentiate an equation over something, when you plug in the number, you can get the slope of at any point of the curve. The slope meaning if it's very steep, then you are rising. If you increase x, you are rising very fast. If it's not steep, when you increase x, the output of the equation is increases slowly. So it's the rate of change of the amount in, right? Now, if the slope of the profit curve is flat, that point will yield the highest profit. Why? Because at the top there, if you input the equation, or if you put x where the curve or the slope is flat, that means we are at the peak. Yeah, we are at the peak. So what we want is using this, differentiate the profit equation to use that to find where is that sweet spot where the output of the equation is 0. If it's 0, meaning it's at the inflection point, that will be our most, the x that yields that will give you the most profitable trade. Okay, all of this is Form 5 maths. I don't know if you remember Form 5. Yeah, you should have learned this in additional maths, in Ed Maths. So it's nothing new, right? I'll give a quick example. This is Uniswap V2. It's a bit more easier, so we'll just go through quickly, right? So we start with RX and RY. That is the reserves in the pool. So 10 ETH and 20,000 USDC, that's 200,000. So K here, where K is a constant that must remain the same. K will be 200,000. Okay, simple enough. If you remember the shape of the graph, this will look like 1 over x. So if you remember, what is the shape of 1 over x graph? It looks something like this, right? I forgot what it's called in English, but yeah, it looks like that, right? So it's continuous. So there's no discrete places. It's all very continuous, a continuous curve. Now, we are putting in x, we are taking out y. While we are doing that, k must remain the same. And so you can put it into the equation. You get rx plus xf multiplied by ry minus y. So x is the input, y is the output. There's an f there. F is the fee factor. So if the fee is, let's say Uniswap V2 is 0.3%, then f is 0.997. So you can think of it as the amount after you've subtracted the fee. The fee is for the liquidity providers. Okay, you have the f there. You can rearrange this equation to find y, and that's y. Very simple. Just move things around. There's a k there, so you can substitute that k with rx, ry, just like the first equation. And we already have the full equation to calculate how much would you get if you swap or if you sell x ETH, right? So here, I'm putting in 0.5 ETH, I get back 949 USDC. This looks a bit weird. Why? The pool is 1 ETH is 2,000 USDC. So if you calculate that, 0.5 ETH should give you 1,000 USDC. But here, you are paying like, I don't know, 50 USDC fee. So this is the issue with price impact. So this is why liquidity is important. It's going to be a big difference if the pool has 10 ETH and 20,000 USDC and 100 ETH and 200,000 USDC. This means if it's more liquid, then you'll pay less in terms of price impact. This price impact is directly because of the equation here, right? You have this curve here. If it's not very liquid, then you're going to move fast, or you're going to move not a lot in the curve. The difference between A token spend and B token gain in the graph. Yeah, so this is price impact. So very important that we take this into account when we want to figure out what's the optimal size. Okay, now we go a step further. We introduce a second pool. So you can see that Y there goes into the pool 2 of 20 ETH, 20,000 USDC pair. So how do we proceed? We have this equation just now, which is Y. Now we plug this into the same equation for pool 2, right? That Y there is basically everything there. So you can put everything in there. You get your X out. Here I use X out. So X out is the final output amount. And you have your profit equation, which is X out minus X, which looks like this. You differentiate by x, meaning you differentiate by the original x at the start. Yeah. So this gives you the curve, or sorry, the slope at any point of the curve, right? So, and then finally, the optimal x is when the differentiation of profit over x is equal to 0, aka the root. So this 0 looks like this on the chart, the flat at the top. Okay, so that's basically how we can think about optimal sizing. This is quite hard, right? Because you're going to be differentiating a lot of stuff when you substitute in the y. So I did that. I tried doing that some time ago. But actually, modern tools can do this for you. Very, very powerful, right? There's a library called SymPy, which is a Python library for symbolic mathematics. You give it symbols, and it helps you to solve it. It's included in Anaconda. You can download it straight away, and then you can play around. It looks like this. This isn't the actual equation, but you can use it. This will hint you at how to solve it yourself, and get the equation yourself. Yep, very, very straightforward. Okay, so that's Uniswap V2 arbitrage. Now, there's some difference with Uniswap V3. Why? If you look at, this is how a Uniswap V3 liquidity distribution, I don't know what's it actually called. You can see there's different levels at different price range. So you can think of this as a price range, right? There's different levels. So if you recall from TC's talk, there's someone who specifically wants to provide liquidity here. And then everyone else is providing liquidity all over the place. So up to them. So that's why you have these peaks and troughs. It's because some people decided that they only want to provide liquidity there. So this is someone's liquidity position. When you look at what is the current price of a Uniswap V3 pool, you look at the middle, everything on the left is one token, everything on the right is another token. What happens, let's see. So when you trade Ethereum, what happens is here it'll change, or when you sell Ethereum, Ethereum goes into here and then you take out USDC. You do that until it goes down, and then it will move to the next liquidity price range. Yeah, so this is how it works. So just exchanging from ETH to USDC. If you take it, then you get it. You put in the ETH, you get the USDC. This becomes a ETH liquidity. Right. Because there's all of these discrete price ranges, it's called ticks, but I'll just use ticks. Yeah, because of this, we cannot derive a closed form solution. Why? Because each tick has a different liquidity depth. Right, see here, every time we cross it, the equation becomes different. So we cannot use closed form mathematics to derive what is the optimal price. It looks something like this, right? When you do it, you have these different conditions or different values for different liquidity ticks. Okay, so let's say if you sell Ethereum, get USDC. You will put Ethereum and take USDC out. That middle part will become ETH. If you trade in a big enough size, it'll shift to the right, like that. Yeah. So that's how the current price moves for Uniswap V3 pool. Right, so how do we find the optimal size? Okay, one method you can do is binary search. This one's quite simple. First, you calculate the profit at a small size. You just start with a really small size. We call that X low. Let's say it's here. Then you double it, you double and double and double until you find that the profit is going down. So when you find that value where the profit starts to go down, you can mark that as X high. Okay, then what you can do, you check the middle point of the two to see what is the profit. Right, if it's greater than X low, then you can set X mid as X low. Or you can set X high as X mid, whichever. I think you can understand. Okay, yep. So you just repeat this every time. You calculate the low, calculate the high, and then calculate the midpoint. If the midpoint is higher than the low, you set it as a new low. Or if the midpoint is higher than the high, you set it as a high. I don't think I explained that correctly, but I hope you understand. But you will run into some issues here, and that's for you to solve. But it's one option for you to kind of try and find the output. So let's say the middle point between x min and x high is here. Then you'll get closer and closer to the peak. Yeah, you might run into issues, so it's an exercise for you to figure out how to solve that. But this is one option. Another one, I think this one is most likely used by everyone. So it's called Newton-Raphson, right? So the trick is, maybe I'll explain the trick at the end. So if you want to find the root of any function fx, you can use its derivative, f prime x. Again, the derivative shows you the slope. If you know what's the slope, then you know how much you need to move x to get to the root position. So you're using the steepness of the slope as one of the variables for you to know in what direction and also how much to move x so that you reach the peak faster, right? So let's say we have fx, we use the derivative f prime x. So given a function fx, the derivative shows the rate of change of fx at point x, okay? So the slope here, I'll show different slopes. You can see the earlier one is very steep. When you get close to the middle, it's a bit less steep. If you go to the end, it's the other direction. So it gives you a direction and also a magnitude of where to move. So using this rate of change, we can better estimate how much to change x and in which direction in order to find the root. This also means that we can approximate the root of fx in less iterations versus the binary search, right? In the first example, we just used the midpoint, but in this example, we used the steepness of the slope to figure out what's the next best value. Okay, you need to remember that we are trying to find the root of the derivative of the profit equation. So we need to use the second derivative in this equation, right? Our fx there is actually p prime x. We want to find the root of the derivative. So we need to use the second derivative in the Newton-Raphson method. So I'll just show how this works, okay? First, you pick and estimate initial size x based on liquidity. You wouldn't put more than what the liquidity is in the pool. So you just estimate maybe a 10th or a 100th, yeah. Just as a quick starting point. You calculate the derivative using a finite difference. So, okay, this might look a bit confusing, but it's very simple actually. What you are doing here is you are adding a h. The h there is a small number of your x0. So what you're actually doing is you're calculating the just bit above. So you can see there's a dot there. You're calculating just a bit above and just a bit below. From here, you can already make the steepness of you can figure out the steepness of the slope. Yeah, this is the way. So I believe this is what it's doing. So just calculate the top part, the bottom part, just a bit. So from here, you can already estimate the slope, the steepness of the slope. Okay, you calculate the second derivative. So it's a bit longer, but it's still the same. You are still adding this h value, just a fraction of your x0 to get the second derivative. Okay, this one is the important part. You have x0, you want to find what is the next best estimate of the root x1. So what you do is you just x0 minus the first derivative over the second derivative. So you get your new x1. This new x1 might be closer to the root. Okay, then what you do, you repeat all over again. You do it from the first step, you use x1 instead. Yeah, so you're going to do this a few times to get maybe x3. And x3 might be already good enough as the peak of the curve for you to execute the arbitrage. Yeah, so this is another example. This is also used in, let's say, stable swap. Yeah, a Newton-Raphson method. I think you'll find it multiple times if you're a part of DeFi development, yeah. Okay, so calculating P derivative and the second derivative of P might be long, but you can squash it into this one whole function on the right. Yeah, just squash everything into one function and you just repeat. Yeah, so this is just a cheat sheet. I don't know if you noticed, this is ChatGPT. So thank you, Mr. ChatGPT, for this. Okay, that's it. Yeah. When was this? This was December 2022, quite long ago. I made this joke. I said there for fun and profit. Who knows what's the joke? Or who understands the joke based on the graph? Okay, yes? Yeah, correct. 0 is here. So it's not even profitable. Even the peak of this isn't profitable. And I can also say it wasn't fun. Yeah. So that was the joke behind this tweet. This one was actually a stable swap, some kind of stable swap pool, a stable swap arbitrage. So it doesn't have to be V3. It can be anything else as well, to use this method of thinking to figure out the arbitrage. Okay. I have one more thing to show. You can get let me just show this one. Who knows who's this guy? Okay. This was the event, I think 2 days ago or something. Yeah. So you know CZ met Anwar Ibrahim, right? And then after that he met the second most important person in crypto. Okay lah, no, just kidding. But yeah, I was able to meet us. I was like, okay lah, I work in this industry. At least once in my lifetime, I should see him face to face, in my own eyes, and I did. Okay, you can get the slides here. So if you want to refer back on the math, yeah, I'll just leave this here. Any questions? Sorry? Okay. Oh, you don't know about the number 4. Okay. I hope I get this right. That's a good question, yeah. I hope I get this right. So the story is that CZ made a tweet saying the 3 rules to succeed in crypto. There's 1, 2, 3. And then he added a 4th one. The 4th one is don't believe in FUD. So fear, uncertainty, and doubt, number 4. So what happens is anytime there's any FUD about Binance, he just tweets under the tweet 4. So everyone knows what he's talking about. Don't believe the FUD. Okay, so this 4 thing was going on for quite a while. And then last year, he was indicted in the US for financial crimes based on their finding. And I think he agreed to go into jail. He went to jail for 4 months. So this is the kicker. I think the fine also to Binance was 4 billion. So you can imagine, I did a 4 there, and then everyone else was doing the 4. So he was quite a good spot. CZ was talking about crypto or digital assets in Malaysia. Very insightful. So yeah, what can Malaysia do to succeed in crypto compared to, let's say, Abu Dhabi? Abu Dhabi is doing a lot in crypto and has managed to grow a lot, right? Compared to Singapore, his new venture, Giggle Academy, right? Why does he want to do online education? There's a lot of thinking into that. Like, you can make educational content very cheap. You know, a teacher can make educational content for 12 years worth of content in like a few months, right? That's not the issue, right? The issue is how to make it engaging for kids. Other than that, what did he talk about? Capital controls, things like that. So that's why he went to see Anwar Ibrahim also, yeah, to talk about how to make Malaysia the next crypto hub or something. And that is good in my eyes. Yeah. Any other question? Okay, I think that's all. Okay, thanks. So, okay, let's see.